All right, here's the review for Chapter 5. Going through these problems, what I'm going to do is deal with problems that would work with this golden page as much as possible. The golden page works with problems that are in the first 3 rows and only problems that are adding or multiplying or dividing. So any problems that are adding or subtracting, I can't use the golden page for it. So the way I'm going to do it is I'm going to deal with all my exponent problems first. Then I'm going to go to all my radical problems, and then I'll deal with the problems that had adding and subtracting in them. So I actually started this one. The first thing I'm going to do with this page is the negative exponent is I'm going to deal with the negative exponent, and that says to move it to the bottom. And then a 1/3 power is like a cubed root. So I'm just taking the cubed root of 27, which I can do on my exponent table, and that gives me 3. So I'm going to skip this one for now, and I'm going to go to this problem. So the first thing I want to do, or not that problem, sorry, I'm going to go to this problem, is I want to look for any parentheses. That's what this page tells me to do first, and I don't have any. And then I want to organize by the basis, so I want to move my negative exponents, and I don't have any of those, but I do have a lot of other things I can organize. So 12 and 2 are just regular numbers, no exponents with them. And as I organize, I'm going to cross things off. I'm going to put all the x's together, and none of the x's are going to move from bottom to top or anything because there are no negative exponents. So x squared, x to the 4th. And then I'm going to put all these y's together. And again, nothing moves from bottom or top because there are no negative exponents. And instead of having one big problem, I now have 3 little problems. So first, this is just 12 over 2, 12 divided by 2, which is 6. These x's, so the idea here is now with bases that are the same, you add or subtract your exponents. And if you do have fractions, which we don't, we'll go for common denominators. But these are just regular numbers. So when I'm done here, I have 6 x's, and then here what can happen is these two can just actually cancel out. So when I'm done, I have y squared, and it stays on the bottom, and that's my answer for that one. The next problem I'm going to go to will be this one. So the first thing I'm going to do is deal with the parentheses. That negative exponent is going to go in here, and when I distribute in, the exponents multiply. So I'll be taking 2, or 2 over 1 times negative 1/3. I do not need common denominators when I multiply, so this just becomes negative 2/3. So right now I have 1 over x to the negative 2/3. And then the next thing I do is, after dealing with parentheses, as I organize my bases, I move my negative exponents. So this negative moves to the top, and now it's positive. And then that's it. I don't have any other bases. When I'm done with that one, I'm done with that one. All right, next problem. This has exponents. So the first thing is I see parentheses. I'm going to distribute that 1/2 to each thing, the 25, the a, the b. So this becomes 25 to the 1/2. And then I'm going to be multiplying the half with 10. So it's just half of 10, which is 5. And I'll be taking half of 16, which is 8. And then I want to organize by the bases. Well, there's only 1 in 25 base. There's only one a, there's only one b, so this is organized. And the only thing I can do at this point is realize that 25 to the 1/2 is like the square root of 25. So I want to turn that into a 5. And the a and b will stay like this. These do not have the same base. It's only with bases that are the same that I add or subtract my exponents. So I will leave the problem as it is here. Okay? All right, those are my exponent problems. Let's go to the radical problems. So, and again, only the ones that have multiplication division. I'm going to be using the other side. So this one has addition and subtraction. I'm going to wait. So I'm going to start with this one. The first thing I want to do is, it says combine like radicals. Multiply, divide, simplify, combine any like bases. This is already combined. There's nothing I can do. X's can't combine with Y's or Z's, so this is it. Then it says I want to make a factor tree. I want to make a factor tree for just the regular numbers, the coefficient, the regular sized numbers. So I'm not going to talk through this part. So when I'm done, 32 can be written with 1, 2, 3, 4, 5 2's. And now what I want to do is, excuse me, make the denominator perfect. There is no denominator, and now I want to take out the perfect stuff. So what I'm going to do on this one is just show you the perfect versus the not perfect. So here's my perfect, here's my not perfect. And remember, there's a little 2 here. So of these 5 2's, 4 are perfect and 1's not. And I'm going for numbers. What's the biggest number that 2 can go into perfectly? And of the 5, it can go into 4, and then one's not perfect. I still have 5 2's. They've been broken up. So of the 3 x's, 2 are perfect, but one's not. Of the y's, 8 are perfect, but one's not. And the z's, I'm going to have to write underneath, all 8 are perfect. And now I take out the perfect stuff, and I take it out. The 2, the x, the y, the z, these all come out. It's just a matter of you putting new exponents with them. So 2 goes into 4 2 times. 2 goes into 2 1 time. 2 goes into 8 4 times. And 2 goes into 8 4 times. So this is great, but I'm not going to leave it as 2 squared. I'm going to change the 2 squared into 4. And then the not perfect stuff will just come along. So the 4 is now there in its place with all of this. And there's not a lot of room, sorry about that. Next one, the first thing I want to do is combine like radicals. Again, multiply, divide, simplify any numbers, combine any like bases. So I'm just looking inside the radical in this fraction. Is there anything I can do to simplify it? No. Then I want to make a factor tree. And again, you don't have to do these steps. Some of you will get better at these problems, but 25 as a factor tree is 5 squared. And then I want to make the denominator perfect. Well, it already is perfect, so I don't have to do anything there. And then I'm going to take out the perfect stuff. So as it turns out, because there's a little 2 here, these are both perfect. So the square root of x squared is x, the square root of 5 squared is 5, and that one's done. All right, this is an addition subtraction problem. I'm going to wait. All right, let's go to this one. So again, the first thing I want to do is make it one radical. If it's not, it is. I want to combine anything, simplify anything in here that I can. I can't. So next thing is I'm going to make a factor tree. So a factor tree for 8. 8 turns into 3 2's. Here comes the rest. And again, you don't have to do all these steps. I'm just going to break them down for you guys. So then you want to take out, it actually says make the denominator perfect. We don't have a denominator. And now we're going to take out the perfect stuff. So what's perfect? Here's my perfect. Here's my not perfect. So all the 2's are perfect. All the x's are perfect. All the y's are perfect. And of the 4 z's, 3 are perfect, but one's not. So I know this is really squished. But now these are all going to come out. So 2 is going to come out, x and y. And the exponents that go with them. 3 goes into 3 one time. 3 goes into this 3 one times. And 3 goes into that 6 2 times. This 3 is part of this cubed root here. And then 3 goes into that z one time. And you don't need the first powers. I'm going to leave them there. And then this other lone z just stays in there. So here's my answer for this problem. All right, next one. So this is a problem where I do want to combine them because they have like radicals, the same index. And as I do that, I want to multiply, divide, simplify any of the numbers, but then I want to combine any like bases. So for instance, I can take 27 times 9, and again, this is not always the best way to do the problem, but I'm going to stick with the same way every way, and that becomes 243, and then combine my x's. There's 5 of them. Now I want to make a factor tree, so I'm going to actually just undo what I did. Here's a factor tree for 243. So I know that 27 and 9, the two numbers that I just multiplied. 9 breaks down to 3's. So when I'm done, I have 1, 2, 3, 4, 5 3's. And then it says make your denominator perfect. Again, I don't have a denominator. Take out the perfect stuff. It's all perfect. So these can both come out as 3 and x, and they would both have first powers because 5 goes into 5 one time. But this time I'm not going to put the first power. All right, this one is one radical. We're already at that step, so I'm going to make that factor tree for 64. And again, it doesn't matter how you start your factor tree, we will all end up with the same numbers. So when I'm done with 64, I have 6 2's. And now I want to take out the, so make the factor tree, make the denominator perfect, don't have that, take out the perfect stuff. So now I'm going to take out the perfect stuff. So it's perfect, here's not perfect. Whoops. So all the 2's are perfect, And of the 4 x's, 3 are perfect and 1's not. Oops, sorry. And none of the y's are perfect, so they're all going to go in there. And now the 2 and the x can come out. 3 goes into 6 2 times. 3 goes into 3 1 time. This stuff is just staying in there. And again, 2 squared, they wouldn't leave it as 2 squared. They would actually turn it into 4. But since I don't have that much room to rewrite it, I'm just going to leave it like this. So 4x times the cubed root of xy squared is my answer. All right. One more here. Okay, so the first thing I want to do is, again, combine radicals. They're already combined, but I do want to see if I can simplify any of the numbers or the bases. So, for instance, 18 and 49, I can't simplify that fraction, but the x's I could actually simplify. I could rewrite this as x to the 4th on top. I'm just going to 5 x's and 1 down here. I would subtract those. So that would be great to do. It'll save you time later. So I simplified. I combined any like bases. And now I'm going to make a factor tree for the numbers. I'm going to kind of do this in one step. So 18, I'm going to rewrite as 2 and then my 3's. I don't have enough room, so I'll put it here. And 49 breaks down into 7 squared. Okay? So now I want to make the denominator perfect. And these 7's are perfect, but the z's are not. So what I'm going to do is have to rationalize. So I'm going to come over here. I'm going to rewrite the problem a little nicer now. So 2 and 3 squared. Here's just the numerator rewritten. And here's the denominator rewritten. But now I'm going to make it perfect, and this is the rationalizing the denominator. So what I'm going to have to do is build this up with another square root. So again, the 7's are already perfect because there's a little 2 here. But of the 3 z's, I need 1 more to make it perfect. So now that I have that 1 more z, so I'm going to run out of room, so I'm going to go on to another piece of paper. Then it's what I'm going to have to do, and we actually added this step. We hand wrote it here. I don't have it written on mine. We are going to combine the numerators and combine the denominators if we had to do this step. So let's combine the denominators first. So here's my new denominators. 7 squared and z to the 4th. And the numerator, just here we go. I still have 2 times 3 squared and x to the 4th and y to the 4th, but now there's that z in there. And now I want to take out the perfect stuff. And I'm not going to make the perfect and not perfect on this one. I'm just going to take out the perfect stuff. So 2 is not perfect. It's going to stay in there. 3 is perfect. It comes out. X to the 4th is perfect. It comes out as x squared. Y to the 4th is perfect. It comes out. So these all came out. And the z is not perfect. There's not enough in there, so it's going to stay in there. As for the bottom, well, the denominator, we made it perfect. So this will come out. 7 squared will come out as 7, and z to the 4th will come out as z squared. And again, I'm just using the little 2's that are there. And 2 goes into 2 1 time. 2 goes into these 4's 2 times. And same thing happens here. So when I'm done, this is it. Because we simplified early in the beginning with these x's, I didn't have to do any simplifying at the end. So try to simplify your fractions if you can. All right, next part. Let's do the adding, subtracting problems. Okay, so adding, subtracting is a little different if you can. All right, next part. Let's do the adding, subtracting problems. Okay, so adding, subtracting is a little different. You still need to get rid of the radical down here, but you go about it through the thing called the conjugate, which means I'm going to multiply this by the added version of the denominator. And what should happen is these radicals in the bottom will just go away. So I'm going to start with the numerator. I'm going to multiply. So 2 is going to visit the 1, and it's going to visit the radical 5, and I get this. And then here comes the bottom. So first 1's going to visit, and I get 1. And it visits the radical 5, and I get radical 5. And now this is going to do the visiting, and it's a negative, so when I put it here, it's going to be subtract radical 5. And when it visits this, again, because that's subtraction, I'll have another subtraction here, and I'll get the square root of, putting these two together, 25. So what will happen is these will cancel out. The square root of 25 is 5. So when I'm done in my denominator, I have 1 minus 5, and that'll just become negative 4. So when I'm done with this problem, my answer is up here 2 plus radical 5 over the negative 4 that was there. And then that's it. I cannot simplify these. These are added together, and adding and subtracting stick together. You either take all of this or none of it. Next problem. So I want to be able to subtract these, but again, adding and subtracting is really picky. So what I'm going to have to do is simplify this radical so that they're able to add. Now, 3 that's it. This is simplified as it can go. If I made a factor tree for 3, that's all there is 1 and 3. And there's not enough 3's to come out. So this is just going to be there. But 12, because this is a square root, I'm just going to go about this the way we used to do this. And that's all you'll have on the test is a square root version of a problem. But the square root of 4 is 2. And now I can subtract my radical 3's. So I'm describing how many square roots of 3 I have. And here were 5 and here were 2. So when I'm done subtracting, I have 3 of them. And that's it. You can't multiply and make this 9 of any form because they're not similar enough. So this problem's the same way. You want to try to simplify the radicals so that you can add or subtract them. So 5 is simplified. It just stays that way. But 45, I can break into square root of 9 and square root of 5. So this one just comes along. And then the square root of 9 is 3 with the radical 5. And now how many radical 5's do I have? I have 5 here and 3 here. Take away those 3. And I have 2 of them. All right, next part. Here's one more, similar to the problem up here. So again, with the radical and adding and subtracting, I'm going to use that thing called the conjugate. So I'm going to use the added version. And again, you're going to see all those radicals in the denominator disappear. And some of you have figured out the shortcut, but again, I'm not going to be showing you that shortcut. So first 2 does the visiting, and you get 6, and you get 2 square root of 5. It doesn't become 10. They're not similar enough. And now the bottom. So first 3 is going to visit this 3, and that's 9. And then 3 is going to visit the radical 5, and that's not 15. It's just 3 times radical 5. And now this is going to do the visiting. And again, because of the subtraction, I'll have a subtraction. And maybe you see already that these will cancel out. But when radical 5 goes with radical 5, because of that, it'll be subtraction, but the square root of 25. And then the square root of 25 just becomes 5. So when we're done in the bottom, I'll have 9 minus 5, which is 4. So my final answer is 6 plus 2 radical 5. And that's a great answer. Some of you might see that you could take a 2 out of both of the out of the top. I could factor a 2 out. And then just to show you this 4, I could break down into 2 and 2. And then those could cancel out, and I could just have this as my answer. So that's great if you see this. This is just fine. All right, let's go to the solving problem. So this is from, I think it was 5-4 in your notes. So our goal is to solve for x. And again, when you solve for x on some of these, when you take the even radical, the even root to solve the problems, you're going to have to look at the fact that you will probably be having 2 answers from there. But in most of these problems, your goal was to, it just depends if you have 1x, so 1x, or 2x's. But either way, your job is to, for instance, I think we first talked about, which ones? Well, we did all kinds. But in a problem like this, I just have one type of x. I want to get x by itself. So I'll be consistently working backwards in the order of operations. All right, so the first thing I'm going to do on this problem is I just want to get that x by itself. So actually, I think this was from 5-1 or 5-2, these types of problems. So first, there is addition subtraction, but it's in the parentheses, so I won't do that yet. So now I'm going to deal with multiplying or dividing. I'm going to divide by 2. That gives me 8. And now I'm going to get rid of the exponent. To undo a cube, I cube root. So I'm going to cube root this side. And I'm going to cube root this side. So this side just leaves me, the cube root and the cube cancel out. I'm just left with x minus 1. But the cubed root of 8, that's an odd root. So it's whatever the calculator says. And remember, on your calculator, this math button is how you do cube roots, fourth roots. But the cubed root of 8 is just 2. It's not negative 2. So now to get x by itself, I deal with the stuff in the parentheses. I add 1 over, and I get 3. So the idea is if I do put 3 back in here, I don't know how well this will show up. If I put 3 back in there, just to show you guys, I should get 16 as my answer. And I do. Okay? All right, next problem. This time I want to get the x by itself. So first, any addition or subtraction, yes, but it's in the parentheses, so I won't do that. Then I move away, don't move it in, the multiplying or dividing, so I'm going to divide by 2 again. That gives me 16. And now to get rid of the exponent, I fourth root it. And now I'm taking an even root. So when I take the even root, this is where I'm going to have 2 answers because I'm taking the even root of a positive number. So the fourth root and the fourth power cancel out. And the fourth root of 16 isn't just 2, but it's also a negative 2. So I'll be solving x minus 1 with 2 and with negative 2. In either problem, though, I have to get x by itself, so I'm going to add 1 here, and that gives me 3. And then I'm going to add 1 here, and that gives me negative 1. Now, we have to make sure that these both work, or are they extraneous? So I'd put 3 in there, I'd put negative 1 in there. So if I did this right, I should get 32. So 3 works. And then this time, I'm just going to hit second, enter, and it's going to recall what I just typed in, and I'm going to go back to the 3, and I'm going to hit second, delete, to insert. I just want a negative 3 to pop up there. Or I'm sorry, negative 1. So I want to so there's 1. And then I'm just going to delete that 3. Push the delete button. So I said negative 3 was negative 1. So if I do this, do I get 32? And I do. So these are both answers that work. Neither are extraneous solutions. All right, in radicals, we talked about that in radicals you might have 1 radical or 2 radicals. If there's 1 radical, which this problem has, isolate it from everything else. And this is isolated. There's nothing else with the radical. There's stuff in the radical, but there's not stuff outside of the radical. And after you isolate the radical, in 5.4 of your notes it says, now work backwards, now get rid of the radical. So to undo a square root, I'm going to square both sides. And that means I'm going to square all of x plus 3. So the square and the square root cancel each other out. And then x plus 3, I don't distribute it in. You cannot use this shortcut when there's addition and subtraction. Again, what it really means is that there are 2 of these, and I would FOIL this. So first I'd get x squared and 3x. But when I multiply here, I get another 3x, which would then total up to 6 of them. And then the 3 and the 3 would give me 9. Now when I look at the problem, this is back to stuff from chapter 3. I have more than one type of x, so I'm going to get x by itself all on one side because I'm going to have to factor. So I'm going to subtract the 2x to join the 6x. And I'm going to subtract the 6 over here with the 9. So when I'm done, I have x squared plus 4x plus 3. And now this is factoring. Simple, easy factoring. Factors of 3 that get me to 4 are 1 and 3. And then I get x plus 1, x plus 3. What makes them 0 are negative 1 and negative 3. And I want to see if I put this in, does the left side equal the right side? So first I'll start with the left one. So square root. And I'm going to do 2 times, what was it? 1, negative 1. And then add 6. And I get this number. And so if I put negative 1 to the other side, do I get the same answer? And I do. So negative 1 works. And now I want to see if negative 3 works. So again, left side, square root. 2 times negative 3. I'm going to add 6. And I get 0. And now I want to see if I put negative 3 in over here, which I'm not going to put in the calculator. Negative 3 plus 3 is 0. So again, both of these answers work. Neither of them, are extraneous. Okay? The other way we talked about this is you could actually just go to the y equals button, put in, so those are for the people graphing calculator, put this in y1 and put it with the x. And then put in x plus 3. And then I'm going to start with zoom 6, and I want to see, do these meet at negative 1 and negative 3? So there's a negative 3, there's a negative 1. So there's the negative 3, and then there's the negative 1. So they both work. All right, next one, with exponents. This is just like a square root. So you could treat it like a square root, or you could look at it as an exponent. But either way, to get rid of 1/2 or the square root of 9x minus 20, you're going to square both sides. And 1/2 times 2 is 1, so I just get 9x minus 20. Or if I squared the square root, I would still be left with 9x minus 20. But that means I got to square this side. And now I'm ready to solve. I have more than one type of x. I'm going to have to factor it, so I'm going to bring the 9x over by subtracting it, and I'm going to add the 20 over. I want x squared to stay positive as I do this. So I need factors of 20 that give me -9. That'd be -5 and -4. And now I get x minus 5, x minus 4, and my two solutions right now are 5 and 4. And again, I want to see if these really work. So the way for any calculator is put 5 in first. Okay, so let's see. 9 times 5, and I'm just going to put the 5 in parentheses, minus 20. And then all of that's going to the 1/2 power. I'm going to use 0.5. And I get 5. And then I want to see if I put, well, and if I just put 5 in here, ignore the squared, I get 5. So 5 works. Now I want to see if 4 works. So again, I'm just going to hit second enter. I'm going to go back to that 5, change it into 4. And I get 4, and that's what I should get on the right side. So these both work. No extraneous solutions. All right, last one. Oh, and I have this one too. Sorry, I didn't realize I skipped that one, so I'll come back to that. So with radicals, isolate the radical. It already is. Now get rid of the radical, square both sides. And now just solve for x. I just have to move the 1 over, and I get 15. So this one I'm not going to type in my calculator, because if I put 15 in here, 15 plus 1 is 16, and the square root of 16 is 4. So I know 15 is going to work. Last one. So with this one, isolate the radical. It already is. Now get rid of the radical, so that means I'm going to square both sides. The square and the square root cancel out. And now to get x by itself, because I have more than one type of x, I got to bring everything over. So I'm going to subtract the x and the 42 over, and I'm going to factor here. So I need factors of -42 that get me to -1. That would be -7 and 6. I make my two parentheses. This is all good mile marker practice as well. And my two answers are -6 and 7. And then I want to see if these both work. So for this time I'm going to use the graphing calculator, clear out these equations, and I'm going to type in the original version, not what I